After watching this lecture, you should be able to describe the hypothalamic control of the anterior pituitary and be able to list the major anterior pituitary hormones as well as the major hypothalamic hormones that control them. Let's take a look at the anatomy and recall that there are 5 major anterior pituitary cell types: the corticotrophs, gonadotrophs, somatotrophs, thyrotrophs, and lactotrophs. And these cell types release specific hormones that are picked up by this capillary network and then carried off to the general circulation. In contrast, antidiuretic hormone and oxytocin, the major posterior pituitary hormones, are synthesized up in the hypothalamus and transported down axons where they're released in a neuroendocrine fashion, picked up by this capillary network, and then carried off to the general circulation. Now, the 5 major anterior pituitary cell types are controlled by either releasing hormones or inhibitory hormones that are made up in the hypothalamus and transported down the pituitary portal system where they act on receptors on these specific cell types. If we go back and look at this first, the anterior pituitary hormones that are released from these cell types, we can first start with the corticotrophs. Now, like the name implies, they're going to be releasing a hormone that's going to stimulate the adrenal cortex, which is the outer 3 layers of the adrenal gland. Now, this hormone is called ACTH, abbreviated here, and that hormone stands for adrenocorticotropin hormone because it stimulates the adrenal cortex. Now, the gonadotrophs are interesting because they secrete 2 hormones, which is the only cell type in the anterior pituitary that does that. And the 2 hormones are LH and FSH, and collectively these are called gonadotropins because they stimulate the gonads. Now, LH stands for luteinizing hormone, and FSH stands for follicle stimulating hormone. Now, even though these hormone names are given for their effects on the ovary, because the corpus luteum and the follicle are ovarian structures, the gonadotropins have very important effects in males as well, because the testes have receptors for LH and FSH, and it regulates male reproductive function as well. Somatotrophs release a hormone called growth hormone. Sometimes it's called somatotropin, and that's abbreviated GH. So GH stands for growth hormone. And growth hormone stimulates growth of the body, mostly through its effects to stimulate another hormone called insulin-like growth factor 1. And together, growth hormone indirectly through IGF-1 stimulates the growth of the bones and various other structures in the body. Thyrotrophs release a hormone called TSH. That's abbreviation for thyroid stimulating hormone because it stimulates the growth and function of the thyroid gland. It's also called thyrotropin. So TSH and thyrotropin are interchangeable terms, just like LH and FSH are interchangeable with gonadotropins. Lactotrophs, the final cell type, release a hormone called prolactin, abbreviate that PRL, and prolactin has effects on breast tissue to stimulate milk production. So these are all the anterior pituitary hormones, with note that the gonadotrophs release 2 hormones, while all the other ones release 1. Now let's talk about the control of these hormones through the hypothalamic hormones. Now we start off with the corticotrophs, and the hormone that's going to control the release of the corticotroph ACTH is corticotropin releasing hormone, abbreviated CRH. So CRH is going to stimulate the release of ACTH. ACTH, again, it stands for adrenocorticotropin hormone, so it makes sense that corticotropin releasing hormone is going to stimulate the release of ACTH. Now, gonadotropes, they secrete, again, two hormones, the gonadotropins, but they're under the influence of a single releasing hormone, and that would be called gonadotropin releasing hormone. Because these are the gonadotropins. And this is abbreviated GnRH. And again, that would be a plus. And somatotrophs are under influence of growth hormone releasing hormone. So we can write that in. Growth hormone releasing hormone. And that's abbreviated GHRH. And that's a plus as well. And the only thing that's different with the somatotrophs compared to the other two cell types is that there's also an inhibitor called somatostatin, and we can abbreviate that SST, but it's mild. It's not the dominant controller of the somatotrophs. And we can write in the abbreviation for SST. That stands for somatostatin. But it is important to keep in mind that somatostatin can do this because in individuals that have somatotroph tumors producing lots of growth hormone, if this occurs in childhood, those individuals can become giants. One of the drugs that you can give to treat that, to suppress the release of growth hormone, would be a drug that acts like somatostatin. So it's a good idea to know that somatostatin can have this effect, although it's in normal physiology, it's not a dominant controller. Now, if we go and look at the thyrotrophs, thyrotropin releasing hormone is going to be the major controller there, because another name for TSH is thyrotropin. So thyrotropin releasing hormone is abbreviated TRH, and it's a plus, of course, because it's a releasing hormone. And just point out that somatostatin can have a mild effect there as well, but it's not dominant. So still, the dominant control of these four cell types is releasing, with a little bit of a mild effect of an inhibitor, somatostatin. Now, the major control of lactotrophs is a little different than the other cell types because it's under the influence of dopamine as its primary regulator. So dopamine, abbreviated DA, inhibits the lactotrophs. And dopamine is also unique because it's the only hypothalamic hormone listed here that's not a peptide. It's a modified tyrosine, which is an amino acid, and that has the effects to suppress prolactin by binding to dopamine receptors in the lactotrophs. Let me just also point out that TRH can have a mild stimulation of the lactotrophs, and this can be important in certain circumstances where TRH is very high. But just like somatostatin, it's not a major regulator of lactotrophs. So now what we can do is we can summarize what we've done here by going back to our anatomy picture and seeing that we have our releasing hormones, CRH, GnRH, TRH, and GHRH, that travel down the portal system and act on their respective receptors on these cell types to stimulate the release of hormones. And then we have our two major inhibitory hormones, somatostatin and dopamine, with dopamine being the major inhibitor of lactotroph release of prolactin. So to summarize again, you should be able to list the major hypothalamic hormones that are listed here: CRH, GnRH, GHRH, TRH, and the two major inhibitors, somatostatin and dopamine, as well as the major anterior pituitary hormones, ACTH, gonadotropins LH and FSH, growth hormone, TSH, and prolactin. And that concludes the lecture on hypothalamic control of the anterior pituitary.